Welcome to A&P Virtual Tech Tour. Hopefully you can visit us in person soon, but for now let's explain why you should be using Braid. Let's start with our history. A&P is a seventh generation family-owned company run by Annie Head. Atkins & Pierce, our former parent company, started in 1817 and is still operating as a traditional braiding company, making automotive insulation, candle making, and drapery cords. In 1995, Annie spun off A&P Technology and fully incorporated as a standalone business in 1997, focusing on engineered textiles and reinforcements for composites. Now let's show you what a standard off-the-shelf braiding machine looks like. This is a 56 carrier Wardwell machine. Braiding is naturally a 2x2 twill, but can easily be converted to a diamond braid or a plain weave by taking out every other carrier in both directions. We have this braider set up to produce a triaxial construction, meaning we have yarns feeding from under the braider, running lengthwise in between the bias yarns. The bias yarns can be formed at any angle between 10 to 85 degrees, providing for optimal construction for the composite part. A&P's equipment is very different in terms of complexity and scale. A&P designs and produces all of its own support equipment and braiding equipment in-house and has a unique line of braiders ranging from 8 carriers to 864 carriers. Our 864 carrier machine is 45 foot in diameter. With this process, A&P produces 3 product forms: preforms, fabrics, and sleeves. Our braided preforms are net shaped with optimized fiber architectures. With this technology, we can produce structures such as rocket nozzles, stator vanes, aircraft frames, and drone bodies, all net shaped. Preforms are often produced using an overbraiding process. A&P has many dedicated overbraiding cells, including the world's largest. Overbraiding allows for precise control of the fiber angle and thickness on complex shapes. It is an automated, hands-free process. Our fabrics are well known for their optimal fiber architectures and can be made as broad goods or contour fabrics. Our contour fabrics are used for such things as engine containment systems and wheels. Our standard fabrics are Bimax, which is a plus or minus 45 degree material with small stabilizing axial yarns. TX45 is a plus or minus 45 degree material delivered on a poly backer with no axial yarns, allowing for extreme conformability. Our 45 degree fabrics offer significant cost savings instead of having to cut 0.90 fabric on the bias to get 45s. Our most popular fabric is Kiso, 0 plus or minus 60 degree fabric with 33% by weight in every direction, offering quasi-isotropic-like properties in one layer. And our only non-braided product, Zero, which has hot melt on one side, creating very little crimp in the carbon filaments. A&P offers braided sleevings from 1/4 inch to 36 inch in diameter. These sleevings are used on softball bats, hockey sticks, aircraft ducts, propellers, as well as many other applications. Now let's show you how these products are used. We'd like to walk through our display area, showcasing the customers and industries that benefit from Braid. We have several customers that use our products for bridges, both over the road and pedestrian. This includes bridge repair for aging concrete, as well as braided arch supports that are filled with concrete and become the structural member of a traffic bridge. Kiso is the product of choice for tooling materials, as well as radio and satellite dishes, mainly because of the ease of layup without cross-blind, as well as consistent CTE values. In situ pipe repair for gas, water, and nuclear plants is also a great application for our braid's unique ability to optimize angle with ease of wrapping. A&P produces tons of material per year for insulation for cars and over-the-road trucks. These highly texturized glass materials offer insulation values sufficient to break down emissions or protect engine parts from high temperatures and operating conditions. A&P has several customers producing carbon wheels for lightweight, performance, and appeal. We are also on the 2020 Corvette. Our Kiso material is used to make the tunnel closeout. A&P's involvement in military is long-standing. Some of the applications we are able to speak of include inflatable air beams for Army hospitals and tents, Kiso for sandwich panels of collapsible military shelters, shoulder launch tubes for missiles, and quick deploying rollable structures for antennas and solar array systems. A&P was also awarded an $8.9 million contract from the Air Force to design and manufacture attritable aircraft primary structures. A&P is the world's leader for braided containment systems on aircraft engines. A&P produces contoured fabrics used by GE, Honeywell, and Williams. Braid provides superior impact performance and significant weight reduction. We also produce braided preforms for stator vanes for Honeywell engines, exhaust shrouds for GE's F-110 engine, and sleevings for VVV ducts and engine bearings. A&P produces net-shaped fuselage frames for the 787-8 and have been in high-volume production since 2009. Our braided products are also the primary structure for aircraft seats produced with thermoplastic carbon PPS to meet FSD requirements. Kiso is ideal for carbon-carbon disc brakes, offering one-layer balanced material with even wear. Braided sleevings are widely used for aircraft propellers. Braided sleevings are used for prosthetic and orthotic devices. Braid is extremely conformable, making it the product of choice. A&P got its start in the recreational world and is still widely used for softball bats and hockey sticks because of the ease of layup, the conversion factor, and its impact properties. Callaway drivers use Kiso for the lightweight one-layer balanced layup. We also provide braided fabrics and sleeving for canoes, paddles, hiking equipment, and musical instruments. Now let's head downstairs and check out A&P's prototype lab.
Hello, and welcome to A&P Technology's Engineering Lab. Housed in the lower level of our technical center, it's a great complement to show the variety of things that we can do. Really at the heart of A&P Technology, we want to use our unique technology to create really good solutions for our customers. But due to the broad range of things that we can do, the options sometimes become overwhelming. So this is a great space for our customers to practice our materials and to practice layups, to really get them thinking about braid and to see how to optimally use braid. The first thing we come to on our tour is a simple braiding machine. This is a commercially available machine that we can use to show the basic concepts of braid and how the fibers interact with each other. You can see how the carriers move and how the braid forms up to form your final product. It is well known in the industry that A&P designs and builds all of our own braiding equipment and fiber handling equipment. This offers our customers a huge advantage in the cost efficiency of our products, as well as the variety of what we can offer. But it may not be known that we also make most of our overbraid manuals. This tool not only being light, it also shows a great technique for A&P to make custom contoured fabrics. So what we do at A&P is we'll take our sleeve product, we'll squash our sleeve flat, much like a sock underfoot, and then wrap it around a contoured shape. And what that does is that creates different fiber lengths along the width of the fabric. This allows us to quickly wrap complex shapes where you would normally have to dart, pleat, and cut traditional fabrics. In here, you're going to see an ever-changing amount of braid samples and styles to play with. Not only can we offer options through the different braid architectures and braid hybridization options, we can also add value and different things through the use of powder binders. So at A&P Technology, we can powder bind our fabrics on one side or two sides through different GSM weights to really match your requirements. What that does is that allows you to cut our materials and have everything hold together very well. It also allows you to do debulks, heated debulks, to hold the material exactly where it needs to be through your layup. And then it also allows you to preform things off of the tooling. So this is a great example of how you can have a secondary tool to put your material onto, and through a little bit of heat, you can semi-rigidize that part and then put it on your mold tooling. That allows you to separate the preforming from the mold tooling so that you're not occupying precious time in your mold. Other things that we can do is to actually tackify through powder binder a single toe. We can then take that toe and we can braid it into a biaxial sleeve or a preform. That allows the braided product to still be flexible as it comes off the machinery, and then when our customer receives it, they can heat it to semi-rigidize it to match the shape that they're looking for. At A&P Technology, all of our braided products, whether it's our sleevings, our fabrics, or our preforms, can also be incorporated with thermoplastics. This allows for quick cycle times for our customers. So a couple different options that we can do. With our fabrics, we can get our materials semi-pregged, where a thermoplastic resin is applied to the finished fabric. That can come in a semi-flexible form, or it can come into a billet that's already pre-consolidated. These billets can come in very large sizes, up to 4 foot by 8 foot. In some of our other products, we can incorporate a commingled fiber, which would basically be a carbon fiber that has been disassembled and reassembled with a thermoplastic yarn inside of it. That would allow our customer to be able to retain product flexibility and still have quick molding. Another option that we can do is to take a uni tape and then slit that tape into small ribbons. We can slit those ribbons to various sizes, but then we can braid those and come up with a product. Over here in our tech center is a lot of open space to perform various layup trials. A simple example over here is a baseball bat with a changing cross section. This shape would be difficult to wrap using a traditional flat fabric due to different diameters. But for a sleeve, this is a very easy application. So in here, we're going to show the use of what we call an accumulator tool, where we can apply braided biaxial sleevings over a tool that's a slightly larger diameter. Once the braid is applied to the accumulator tool, it can be twisted or tied and then inverted onto the baseball bat. Here you can see how the braid is inverting on itself, depositing a single layer down onto the baseball bat. When we get to the end, the sleeving can be twisted a little bit to close it up, and then pulled back to add a second layer to the baseball bat. We can see how the biaxial sleeve easily conforms, and we can apply multiple layers very quickly despite a changing cross section. So as you can see from the bat layup, braid is quite a bit different than traditional materials. And if you can think back to the braiding machine that we saw a little bit ago, that machine starts out with a round plate. And on that round plate, half the carriers are clockwise and half move counterclockwise. And what results is a cylinder of braided fabric. And so this is nice because it's continuous with no splices or seams, resulting in fiber continuity from end to end. This is also a great example of a biaxial architecture, meaning there's only 2 degrees of fiber orientation, at a plus and a minus. This acts very much like a Chinese finger trap, where you can push on it and expand the diameter and shrink the length, or you can pull on it and contract the diameter and extend the length. This allows for extreme conformability for changing cross sections in various parts. So things like propeller blades that would be very difficult to splice pieces together can be done very quickly with a sleeve, where you have fiber continuity from the root to the tip, resulting in superior fatigue life as well as enhanced mechanical performance. This material can also be slit open to make a fabric. So it will start out round, we will slit it, unfold it, and we'll get a flat fabric. The next evolution in our braided products is to take this sleeve that we started out with and essentially slit it down the length. We can then unfold that and make a flat fabric. So at A&P Technology, we offer a wide range of fabrics. We have our standards, our Bimax, which is a plus minus 45 degree off-axis material. So anybody looking for high shear strength, that's a great option right off the roll, very cost effective. We also have 0 plus or minus 60 is our Kiso architecture, resulting in a quasi-isotropic lamina, allowing our customers greater design flexibility. But what's really neat is we can actually hybridize our fabrics quite a bit. So we can take different material systems and swap them out. So we can have glass and carbon or aramid blended together to whatever our customer would need. What's also really unique is we can vary the width. So we can have a 1/2 inch wide fabric up to a 65 inch wide fabric. So what that does is that allows our customers to give us the size that they need, reducing scrap, instead of cutting out of a really wide fabric and wasting a lot of the material. Another neat thing that we can do is with the axials. So our Kiso product is triaxial and our Bimax is biaxial. So with the triaxial material, we'll run a 1/3 fiber down the length, and we can vary that fiber. So we can vary the content of the fibers to make it higher or lower. So if you want a 90% uni product, we can produce that. Or if we only want a 10% uni product, we can produce that as well. We can hybridize materials, so we could have high modulus materials in the axials and maybe some softer materials in the bias if you need that additional stiffness. We can also vary the content across the width of the material. So if we want a high degree of axial content in the middle, we can do that with maybe a low percentage on the edges. And we can take that a step further and actually remove the axials on the edges. So in this example here, we have a biaxial triaxial hybrid. So across the top here, we have triaxial material. It's very stable. You can pull on it. It's not going to move. This region here is biaxial, and it's very drapable. So we can handle the contour without wrinkling and pleating. So that's a pretty unique thing that we can do with our braided products. Another example over here is very similar. So it's a triaxial biaxial hybrid, where we have a triaxial region wrapping around the oval shape, and then a biaxial region forming a flange. You can see it very readily forms that flange. And here we have a video to show you. In this video, we can see a hybrid biaxial triaxial fabric in action. So half of this material is triaxial, and the other half is biaxial. So the triaxial portion is down in the video, and it's being wrapped around the perimeter of that oval shape. So again, that provides a nice stable region for people to pull on and be able to wrap very easily. The top half is biaxial. So you can see in the video here how the biaxial material is just naturally draping down and in to create a flange. And then likewise, the outer layer folds out. The changing diameters of a pressure vessel requires the fabric to be at different lengths, meaning you either have to dart and fold the material or stretch and distort it. Through a unique hybrid fabric, we can create zones of highly stable material that can be pulled on by adding axials, and then create zones of highly flexible material like we saw with the baseball bat by keeping the zones biaxial. This creates a very repeatable and quick layup. The third braided product form that we offer at A&P Technology is our preforms. So our technology is pretty unique. If you think back to the machine that we showed, how the fibers basically form a conical area up to a cylindrical product. Well, what we can do is in that conical region, we can actually pull a mandrel. And instead of producing a cylindrical product, we can deposit the fibers directly onto a mandrel. While we're doing it, there's a lot of neat things we can do too. So we can vary the angle along the length. So if we want to have constant fiber angle from one end to the other, we can program that in. Or if you have certain strength requirements that require a little bit more stiffness here, we can design that into the braided product. So what's pretty unique about A&P Technology is since we do build all of our own equipment, we have the world's largest overbraid capacity. So our largest cell can handle mandrels weighing up to 2 tons. They can be 12 feet long and up to 10 foot in diameter. So if you couple that with our 864 carrier, we can produce very large scale overbraided preforms. It's also pretty neat because we can do multiple layers and we can add tackification. So what our customer would get is essentially a semi-rigidized preform that they can drop into their tooling. Another preform method that we can do is something called capstan winding. And this would be something like we mentioned earlier in the video when we showed the very large wheel, where we would essentially take our braided sleeving and instead of slitting it open, we actually kind of squash it flat like a sleeve. And we'll wrap that around a contoured wheel. And what that does is that allows us to build in different fiber lengths from one width to the other. And our customer can wrap this very easily without having to cut, dart, or pleat the material. And we can also change thickness by reducing and adding axial content or partial plies, resulting in a net-shaped preform. This space also allows our customers to get hands-on with their products. In the instances of preforms, usually a lot of measurements are required to ensure that the fiber architecture is correct to match the properties that our customers are looking for. What we can do is we can bring these preforms over to this facility where the customer can do their first article inspections with us to ensure that everything is the way that it needs to be. This allows for a great hands-on experience with our customers to evaluate their final parts and to make quick turnarounds for any changes. Here's the pressure vessel shape that we saw earlier being wrapped. So here it's getting ready for infusion, which we'll do in our large oven. In the composites area of our engineering lab, the first thing we come to is a freezer. It's a walk-in freezer that houses a lot of different braided prepregs, as well as resins that we use to make our prototype parts. As we move over here, you see we have a couple ovens. We have a small oven as well as our large walk-in oven. This walk-in oven is capable of going to 500 degrees Fahrenheit, allowing us to do a lot of out-of-autoclave prepregs, as well as elevated cure temp vartums. So here's an example of a cowl shape getting ready to go through a vartum. Not only do we have the capability of doing soft tooled vartums, we can also do hard tooled RTMs. Here's an example of a simple tubular shape that we make for test articles. We can add our braided material and force resin through under pressure. The closed hard tooling creates a consistent thickness and fiber volume throughout the part. We have full controls for self-heating tooling and a full suite of sensors to record data like temperatures and pressures during the cure. In this area, we have our small 100-ton press. We use this regularly for making test panels for various architectures. This allows a quick turnaround for our customer because we can make the braid, infuse the braid, and then send that off to get tested very rapidly. This is a great example of a compression mold tool that we use for prepregs as well as thermoplastic systems. Over here is one of our RTM panels and our RTM infusion panel mold. We have a wide variety of sizes and thicknesses that we can mold, up to 100 psi of injection pressure and up to 650 degrees Fahrenheit for various high temp resin systems. So speaking of testing, at A&P Technology over the years, we've developed an extensive database of raw material properties, kind of defining all of our different architectures that we can do. So on the table here, we can see that we have a few of the standardized coupons that we can perform. We have our tensile, strength and modulus, compressive properties, in-plane shear, open hole compression, and we can do some more exotic tests like bearing strength, compression after impact, as our customers need them. What's pretty neat is we can use this data to share with our customers so that they can use that in their design of their parts. So the nature of braid, which is pretty neat, is that we start off axis. So maybe it's our plus minus 45 degree architecture, or maybe it's our 0 plus or minus 60. But that off axis nature, is different than the typical 0-90. So because of that, we have to modify some of our coupons to more accurately test our material. A great example of that can be found in this tensile coupon. So this is a great example of our 0 plus or minus 60 degree architecture. In this particular coupon, our 0 degree fibers run continuously from grip to grip. We have our plus 60 and our minus 60 degree bias fibers. And that 0 degree fiber, the fact that it's continuous from grip to grip, when we test this, we generally get very accurate results. If we rotate this architecture and test it transverse, our 0 degree fibers are now running this way, which happens to be perpendicular to the load path. We still have our minus 60 and our positive 60 degree bias fibers, but they do not reach from grip to grip continuously. So because of that lack of fiber continuity, this type of test generally produces pretty poor results. To more accurately test our materials, we've developed this modified bow tie coupon. So we use this in transverse tests, and what this does is it widens up the grip region so that we have fibers that run continuously from grip to grip. We then properly size the gauge region to be the same width of a straight-sided coupon so that we have consistent and comparable results. So we're happy to work with our customers to come up with the best way to test the materials. We actually have a very extensive database where we have been testing a variety of different architectures with a variety of different resin systems. So we have this database at our disposal to reference, to give the data to our customers, to share with them, and to give them a starting point for their designs. So over here, we can also see some ballistic testing that we've done using our fabrics. So we have two panels. The first panel here is a quasi-isotropic fabric. The second panel is a 090 plain weave fabric that has been rotated to make a quasi-isotropic laminate. Our Kiso material has been well known for its impact performance, and because of that, it's widely used in ballistic applications such as fan and containment case systems, really where impact performance is paramount. The reason why Kiso does so well is because it's quasi-isotropic in a single layer. You have 3 axes of orientation, 0, plus 60, minus 60. Each one of those layers is going to react the same way when impacted. So that helps to decrease your interlaminar shear, and it helps all of the layers act more as a net system. With the plane weave, even though you're quasi-isotropic in the laminate, each layer is going to see loads differently. And because of that, you can get internal shearing. So the final results you can see here, we shot a 1 pound gelatin projectile at these panels. This is at 602 feet per second, and this one's at 591 feet per second. So as you can see, the plane weave material was uncontained, while Kiso remained contained for the same weight gelatin projectile. We can also work with our customers to perform some simple component testing to create a turnkey layup, mold, and test facility for rapid turnaround of prototype parts. The test gear elements are 1-inch thick composite discs that are made to mimic the web of a gear system. Inside of it, you can see is a shaft, and in the actual test rig, the shaft gets rotated back and forth. And we calculate and measure the overall rotation angle over several thousand fatigue cycles. This gives us indication and test results as to whether we're getting any sort of failure at the composite to metallic interface. So here's another great example of a testing apparatus that we made. This really shows how we can make the fabric, wrap a pressure vessel, mold a pressure vessel, and then test a pressure vessel. This burst chamber is capable of producing 30,000 PSI using water. And on it here you can see that we have multiple strain gauges ready to record the different strains and movements of the tank during testing. Here's an example of a braided tank that has already been burst. So traditional technology for pressure vessels is largely filament wound, where one layer is put down with another layer of opposing direction on top of it. There's nothing really to hold these layers together other than a resin bond. So in the instances of impact, there's nothing to really stop the interlaminar disbond that can occur. With the braided technology, there's multiple orientations all kind of braided together to act as a net. That helps to increase your damage tolerance, as well as upon failure, it kind of helps hold everything together so failure is not quite as catastrophic. These are a few of the things that we can do here in our engineering lab, but ultimately this space is dedicated to our customer and their needs. So if you have any needs for prototyping or product development, we're happy to help.
Now we're going to take you on an A&P campus tour. We hope you enjoyed your A&P Tech Tour, and in the future when you're designing a reinforced composite, just remember, everything is
Better with Braid!